So here's another circuit where they're asking us to find the Thevenin equivalent for the circuit shown. So that would be between A and B. Notice we have two voltage sources, a 20 volt and a 30 volt, and then we have this 3 amp supply. So this one, a lot of it can be done maybe a little less conventionally. So let's take a look at this, how this might work. So the first thing we want to find out to find the Thevenin equivalent is what is the open circuit voltage from A to B. So when we look at that, we have this 30 volt source, and then we also have this 20 ohm resistor. There won't be any voltage drop with this 15 ohm because there will be no circuit flow with that being open circuited. So this 15 ohm really doesn't play into it. So what we really need to find then is what is the current flowing through here. So we know that up to this point we have this 3 amp supply right here. So that means that we have 3 amps flowing to this point. Now once it gets to this node, we see that we have two 20s. Hold on. Two 20s, and that's in parallel with a 40. So it's basically 40 in parallel with 40. So what that means then is we should have 1.5 amps go this way, and then we should have 1.5 amps go this way, because they're equal resistance in both paths. So that means then this current can't flow this way because that's open circuited. So all this current has to flow down this path. So that means that the voltage through the 20 ohm resistor then is going to be equal to 1.5 amps times 20 ohms, just Ohm's law, V equals IR. All right, and so that being the case, that's going to be 30 volts. So with that knowledge, then we know that the open circuit voltage, that's the voltage drop that's going to be from here to here. Remember, there is none here, there's no current flow. So what we will have then is we'll have our 30 volt source. So that would be coming around this way around the loop. So we hit the negative sign first, so that's minus 30. And then as we hit this 20 ohm resistor, that will be 30 volts. That's what we got right here. So that means our open circuit voltage is 0 volts. 0 volts. So it's a little unusual, but that's what the calculations say. So now we can reset our circuit here. And the next thing we need to find then would be our Thevenin resistance. And that's going to be looking back into this circuit. And remember, when we are calculating the Thevenin resistance, we short out voltage sources. So we can take this voltage source and short it out. So we put a short in place of there. And then we also have a voltage source here. So we short that one out. So it's as if it's not there. So there's the short on it. And we open circuit current sources. So that being the case, it's like this guy is gone totally. But in this case, we don't replace it with a short. We just leave the terminals open there. So looking at this, this no longer has any role in our input resistance, right? So that's gone. And neither does this because it doesn't connect to anything. So then really what we have is these two, the 20 and the 40, now are in series. And so you could replace those with a 60 ohm resistor. So if we redraw that, it'd probably just be easier to redraw it. So it'd be like we had a 60 ohm resistor, and that's going to be in parallel with this 20 ohm resistor, and then we still have our 15 ohm here. So that being the case, we can write this then. Our Thevenin will be these two guys, the 60 and the 20 in parallel, and then that'll be in series with the 15. So if I were to write this for the color, that's going to be 15 plus, and then we'll go to the green, 60 in parallel with 20. And so now I can rewrite that as 15 plus 60 times 20 over 60 plus 20. And when I calculate all that out, this should come out to 30 ohms. So that is our Thevenin resistance. So now, that being the case, we can draw our Thevenin circuit. Normally, we would have a voltage supply in series with a resistor, which we can still draw it like this, where this would be the 30 ohms that we got for our Thevenin equivalent. And this is going to be 0 volts. 0 volts. So really and truly, we could just write the Thevenin equivalent here as just a resistor of 30 ohms. Seems a little odd, but that's the way this one works out.